Hello, we're going to talk about topics 2.8 and 2.9, product rule and quotient rule. Before we get into these two new rules of derivatives, I just wanted to go through a reminder of some previous rules that we've discussed. The first derivative of any constant is 0. If you have a constant multiplier, that constant multiplier can be brought outside of the derivative. And then last but not least, if you have a sum of difference of two functions, you can take the derivatives of those two functions separately. Okay. Now, this case does not apply to a product or a quotient. Okay. So when you have a product of two functions, right? I know this looks a little confusing in the beginning. Bear with me. Okay. This should be an x. So when I take the derivative of f of x times g of x, all right, so I'm multiplying two functions together. What we're going to do is we're going to take the derivative of the first, and then we're going to leave the second the same. And then we're going to take the we're going to leave the first the same, and then take the derivative of the second. Okay, so I want you to see kind of these two big terms that we have here. Again, we're going to take the derivative of the first piece, leave the second, then we do the flip-flop. Then we leave the first, take the derivative of the second. Now, some textbooks use the terminology u and v to represent two different functions. So right below it, u prime times v plus v prime times u. Okay, so you can kind of see it with less parentheses. All right, so let's do it slowly but surely. We'll kind of put it into practice. All right, so I have two functions. All right, I have x plus 1, and I have natural log of x. All right, so if I want the derivative, we're going to call the derivative y prime. What I'm going to do is I'm going to start by taking the derivative of the first piece of my product. So the derivative of x plus 1 is just 1. Derivative of x is 1. The derivative of the 1 is 0. Okay, so I just get 1. Then I am going to multiply by the second piece of my product. Okay, now we're going to add. Now I'm going to leave the first piece of my product the same, and I'm going to multiply by the derivative of the second piece, which in a previous video we discussed the derivative of natural log is 1 over x. Now, if I make this look a little nicer, I'm going to get y prime is the natural log of x plus x plus 1 over x. Now, you can also include here, because we did take the derivative of natural log. In a previous video, we said, okay, well, we're going to have a domain constraint here of x has to be greater than 0, because our function doesn't really exist if our x is greater than 0 or not. So you can choose to put that in there or not. That's up to you. But this is your derivative. Okay. Now, let's do it again. We'll do it slow. All right. So I'm going to take the derivative of this product. So I'm going to kind of underline my two pieces here. So I have a 5x squared, and I have an e to the x. So I'm going to start by taking the derivative of the first piece, which would be a 10x times, leave the second piece the same, plus, now I'm going to leave the first piece the same, times the derivative of the second, which would be still e to the x. So what I have here is I have a 10x e to the x plus a 5x squared e to the x. And if you wrote this as your answer, that's perfectly acceptable. I just want to show some variations on how this answer can be written. So it could be e to the x. If you factor that out, I have a 10x plus 5x squared. So sometimes, if they see something common between all the terms, they might factor it out. They could even factor out a 5x in addition to that. So again, I just want you to know that you can manipulate your answer a little bit. Make sure we can match it to some of the multiple choice questions. Okay, so let's do this next one. So I have g of x. So I'm going to use good notation here, g prime. So we're going to take the derivative of my first piece, which is 10x to the fifth. Okay, so that's going to give me a 50x to the fourth times the derivative of sine is cosine. Oh, hold on. Did too much. We don't take the derivative of the second piece. Okay, we only take the derivative of the first to start. So this should still stay sine of x. Okay, then I'm going to do plus. Now we're going to leave the first one the same. So we're going to leave it at 10x to the fifth. And we're going to multiply it by the derivative of the second. And that is where I'm going to get my cosine of x. So what I get here from my derivative is g prime of x equals a 50x to the fourth sine of x plus a 10x to the fifth cosine of x. Okay? And this would be the derivative or the function to get the instantaneous rate of change. Okay? So this is product rule, right? We also have quotient rule, all right? So when I have a quotient of two things, notice I have a function on top. I'm going to have a function on bottom. I want you guys to see how this is laid out. What we're going to start is we're going to start with the bottom, all right? So it's low, the bottom, times the derivative of the top minus, so that's important, the top times this should be a derivative of the bottom all over the bottom squared. Okay, so again, I like to say it, it's easy for me to remember. Low d high minus high d low all over low squared. Okay, the d is the derivative, right? So low d high minus high d low all over low squared. All right, so let's do some practice. So I want the derivative. So I'm going to call this, let's use a dy dx this time. These get a little long, okay? But I'm going to start with the bottom. So low times the derivative of the top. So the derivative of 2x is just 2. The derivative of the minus 5 is 0. Minus high d low all over the bottom squared. Okay, so I get a 2 sine x minus, now there's no really good way to write this, so we're just going to leave it, all over sine squared x. Okay, and that would be my derivative. Okay, so low d high minus high d low all over low squared. So let's do one more. So I'm going to start with low times d high, should be a 6x, minus high times d low, should just be a 9, all over the bottom squared. Now, let's see if we can make this look a little nicer. I'm going to get a 54x squared minus 12x minus, now we have to be careful with that minus here, 27x squared plus 45 all over a 9x minus 2 squared. So I have a 54x squared minus 12x minus 27x squared minus 45 all over a 9x minus 2 squared. Now, I'm going to combine my like terms, which is going to give me a 27x squared minus 12x minus 45 all over a 9x minus 2 squared. And this would be my answer. Again, that's my derivative. All right, let's take a look at part C. So g prime of x will be low d high, derivative of the top is cosine, minus, I'm going to run out of room here, high, derivative of cosine is a negative sign, all over the bottom squared. So g prime of x is going to be a cosine squared plus a sine squared all over a cosine squared. Okay, now that's an acceptable answer for what we know. But we all know that sine squared plus cosine squared is a 1 over cosine squared, which is the same thing as saying secant squared of x. Okay, and notice, hint, hint, this is tangent. We'll talk about this in very, very soon, actually, in the next topic. The derivative of tangent, it will be secant squared. And we can prove that using quotient rule. Okay, so let's keep going. Okay, talking about a tangent line, right? Determine the equation of the tangent line at the indicated point. So just a review of tangent lines. We need a point. We need to know x comma f of x, and we need to know f prime of x, right? So we need a point and a slope. So my point is going to be 4 comma f of 4, which would be 4 comma, if you plug 4 in, I get 8 over negative 1, which is a negative 8. Okay, so this is my point. Then I want my slope, right? I want to know what f prime of 4 is. Well, we have to take the derivative. So notice that it's a quotient. So I'm going to do low times the derivative of the top, which is just 2, minus low d high minus high d low, which would just be a 1, because derivative of x is 1, derivative of negative 5 is 0, all over x minus 5 squared. So I'm going to write this as a 2x minus 10 minus 2x all over x minus 5 squared. The 2x's cancel, and I get a negative 10 over x minus 5 squared. So now if I want f prime of 4, I can say negative 10 over 4 minus 5 squared. So that would give me a negative 10. So my tangent line, let's use a purple here, is going to be a y plus 8 equals a negative 10 x minus 4, or y equals a negative 10 x minus 4 minus 8. And this would be my tangent line. Now you can distribute and combine like terms. That's up to you, but that is my tangent line. So we need a point and we need a slope. Okay, so let's do the same thing. So I want to know 0 comma f of 0, which would be 0, comma, if you plug 0 in, cosine of 0 is 1. Plug 0 into the denominator, I get 2, so I'm going to get a 1/2. Now I want to figure out f prime of x. So f prime of x would be low d high minus high d low, which is just a 3, all over 3x plus 2 squared. Now I'm not going to go ahead and I'm not going to simplify that. I'm just going to plug 0 into it to find f prime of 0. So if I plug 0, I would get a 2. Sine of 0 is 0 minus 1 times 3 all over 2 squared. So that goes away. I'm going to get a negative 3 over 4. So my tangent line will be a y minus 1/2 equals a 3 over 4. Excuse me. A negative 3 over 4. X minus 0. You don't really need the minus 0. So we can say this is a negative 3 over 4x plus 1/2. And this would be my answer. Okay? So same types of questions, just more complicated functions. We need to take the derivative of a quotient using quotient rule and the derivative of a product using product rule. So you just have to remember when to do it. Okay? So let's take a look at from the kind of the function notation. All right. A couple things I want to point out, just little reminders. The word differentiable, f and g are differentiable for 1 to 4. That means that they're also continuous for 1 to 4. We do know that has to be true. And let's see if we can answer some of these questions using our properties. So I want to know h prime of 1. So let's find h prime of x. Well, this is just a difference. This is just going to be 3 f prime of x minus 2 g prime of x. And if I want h prime of 1, that's just going to be 3f prime of 1 minus 2g prime of 1. Let's figure out what that's going to be. 3 times f prime of 1 is 4, and 2g prime of 1 is 5. So I get a 12 minus 10, which is 2. That would be my answer. Okay. Now, if you look at B, this is going to go along with our lesson today. I want j prime of x, but if you notice, f times g, that's a product. You can't just take the derivative of each piece of the product. You have to use product rule. So we're going to take the derivative of the first times the second plus keep the first. Now take the derivative of the second. And now we're going to plug in 3. So j prime of 3 will be f prime of 3 times g of 3 plus f of 3 times g prime of 3. So let's figure out what those numbers are. So f prime of 3 is a negative 4. G of 3 is 4 plus f of 3, which is 10, and then g prime of 3, which is 2. So I get a negative 16 plus 20, which gives me 4. So the slope at 3 of j of x is 4. Okay. So part C, same idea. I just now have a quotient, so I need to use quotient rule. So k of x is going to be low d high minus high d low all over the bottom squared. So then k prime of 3 is going to be g of 3, f prime of 3 minus f of 3, g prime of 3, all over g of 3 squared. So let's figure out some numbers. G of 3 is 4. F prime of 3 is a negative 4 minus f of 3 is 10. G prime of 3 is 2. All over g of 3, which is 4 squared. So I'm going to go ahead and just write a 16. So I get a negative 16 minus 20 all over 16, which is a negative 36 all over 16. And we can reduce that by a factor of 4. So I'm going to say a negative 9 over 4. And that would be my rate of change, right? So if you look at part D now, write the equation of the line tangent to the graph of k at x equals 3? Well, I need a point, right? 3 comma what? And I need a slope. So I need to know what k prime of 3 is. Well, we just found k prime of 3. That was part C. So that's a negative 9/4. We already did all the hard work. I just need to know what the output is for this function. Now, if you remember, k of x was just f of x over g of x. So if I want to know k of 3, I want to do f of 3 over g of 3. So f of 3 is 10. G of 3 is 4, which gives me a 5 over 2. So I have everything I need. I can say y minus 5 over 2 equals a negative 9/4 x minus 3. And I would write that as a negative 9/4 x minus 3 plus 5 over 2. And that is my tangent line. Okay. Now I like part D. Estimate g double prime of 2. So the second derivative. So g double prime of 2, right? The best you can do is find the rate of change between g prime of 1 and g prime of 3, right? So if I did g prime of 3 minus g prime of 1 all over 3 minus 1, I would get 2 minus 5 all over 3 minus 1, which would give me a negative 3 over 2. And this is an estimate. This is an approximation, okay, of g prime of 2. All right. Let's take a look at the graph. These are the last two questions. So I give you the graph of f. I give you the graph of g. And if you notice, I have f times g here. So I'm going to take the derivative, right? Take the derivative of the first, right, times the second plus keep the first times the derivative of the second. So at 5, what's f prime at 5? So my graph is a touch off here. I don't know what got shifted. Okay, I have a feeling that everything was supposed to be shifted. Okay, where this was moved over just a little bit. Okay, so bear with me here. 1, 2, 3, 4, 5. Okay, so I have this value. So when I do that, I'm at a height of 2. So the slope, I'm sorry, I want the slope. So it's a little difficult when my graph is off. Okay, the slope is going to be down 1 over 2, it looks like. down 1 over 2. Now I'm doing an approximation. That's my best thing I can do because my graph is a little off. So down 1 over 2, and then g of 5 is going to be the output, which is just 1. And then f of 5 is 2. And then g prime looks like it's up 1 over 3. So I get a negative 1/2 plus 2/3. I'm going to get common denominators here. So this is a negative 3 over 6 plus 4 over 6 gives me a 1 over 6. Okay, let's do the same thing. We'll do the best we can with the graph. The graph looks a little bit off. I'll have to fix that. But we're going to do low d high minus high d low all over the bottom squared. Now remember, the bottom is not the derivative. Okay, so we're going to do this at 5 as well. So f of 5 seems to be 2. G prime of 5 is going to be a 1/3 minus g of 5, which was 1. F prime of 5, which looked to be a negative 1/2, all over f of 5 squared. So 2 squared. So let's try to reduce this. I get a 2/3 plus 1/2 all over 4. I'm going to get some common denominators. So 4/6 plus 3/6 all over 4, which gives me a 7/6 all over 4, or a 7 over 24 as my answer. Okay, so again, we can do it from a graph. When you look at a graph, you're just looking at the outputs and the slopes. Okay, when you're doing it from a table, they have to give you those values. And then when you do it from an equation, we have to just use the rules and then substitute. Okay, so again, quotient rule and product rule. All right, hopefully that helped. Email me with any questions.